Whee! That ant is having so much fun spinning around on his CD player. So it spins 24 centimeters, standing 24 centimeters from the center. That's going to be my radius. Rides the CD for 13 seconds. I'm going to keep track of that as my time. And the total distance that it goes is 585 centimeters. So if this ant were to go around and around and around and around and around and around, it's going to make this circle. Envision that ant making a giant red blur. That's the total distance, 585 centimeters. And that radius right there from the center out to the ant, that's the radius of 24 centimeters. So my first question asked me, what angle does the ant turn through in radians? All right, well, that is a tricky question. So we're going to go back to the original description, the definition we had of a radian, which the second bullet point here tells us that a radian describes an angle using the intersected arc length. Okay, that's a distance. Arc length is a distance measured in terms of the radius, which is also a distance. So we're going to take that 585 centimeter total distance, and we're going to chop that up into chunks. Each chunk is going to be the size of the radius. Okay, so one possible way to do this is to find the number of radians. You take that arc length, divide by the radius. Okay, why would you do that? I mean, I'm not sure that you would come up with that on your own. You certainly can do it. It does give you the correct answer. The arc length, the 585 divided by the radius, which is 24 centimeters, gives you this answer. Why would you? That's like coming up with stuff on your own instead of using what you've been taught. So I would not expect you to do that, although it is clearly a very simple calculation once you know what to do. Okay, so these conversion factors that we have in our notes are describing how to convert one type of speed to another type of speed. Speeds are calculated things, right? Linear speed, for example, is distance divided by time. Angular speed, radians divided by time. What if, instead of working with speeds, we just worked with distances? Get rid of this time, get rid of this time. We can convert from a linear speed, rather a linear distance, to an angular distance using this same conversion factor. Right? Whether we're going from speed to speed, whether we're going from distance to distance, the conversion is the same to get from angular to linear. So our conversion factor is the length of the radius is an actual number and the word radius. So I'm going to take that total distance the ant travels, 585. That is I'm going to say that's my linear distance. If I unrolled that whole circle that the ant traveled through, it's a total of 585 centimeters. So I'm going to use the conversion factor of 1 radian is 24 centimeters. Centimeters cancel, and I get 24.375 radians. Okay, so now you can see where that other calculation came from. This 585 is a whole number when we multiply it by 1 over 24. That's essentially the same thing as 585 divided by 24. 585 divided by 24. Arc length divided by radius gives you the radians. Okay. We're going to stick with the conversion factors because we want to do this the same way all the time and not invent new formulas. So let's keep track of that answer. 24.375, and the radians is already provided for me. Next part asks me for the linear speed. So the easiest way to get linear speed is just distance divided by time, since those are both provided to me. So I took the total distance, 585, divided by the amount of time it took, 13 seconds, divide 45 centimeters per second. There, 45. So I certainly could have taken my previous answer of 24.375 radians and divide that by the 13 seconds to get an angular speed and then convert that to linear speed. That seems like way more steps than I need. Although speaking of angular speed, that does show up next. And I'm going to do what I just mentioned a minute ago. To find the angular speed, I'm going to take this 45 centimeters per second. That's the linear speed. And my conversion factor, 1 radian, is 24 centimeters. Centimeters cancel in purple and in blue. I'm left with radians and seconds. Divide in this case, and I get 1.875 radians per second. Radians per second has already been provided for me there. Last question. What is the ant's rotational speed in revolutions per minute? So I'm going to take my previous answer, angular velocity 1.875 radians per second, and use my conversion factor to get from angular speed to rotational speed, which is, in green, 1 revolution and 2 pi radians. So my red radians, my green radians cancel. I'm left with revolutions in seconds. Again, divide. Make sure you keep that 2 pi either in parentheses in your calculator or else multiply 2 times pi ahead of time. And then do the 1.875 divide by 6.28. At any rate, 0.30 revolutions per minute.